Thanks. All right, I'm Benny, and this is Yuan here, and we are team CodeZilla. So we developed an application called Kinect Touch, which basically does the job of a touch screen. It converts any surface into a touch screen. So before I explain the application as such, I'd like to give you a background of why we think this idea is a viable or marketable option. So right now, touchscreens are ubiquitous. It's everywhere. So the thing is, your cell phones have a touchscreen, your televisions are touchscreens, your laptops are touchscreens. So everywhere, touchscreens are quite popular now. Even smart boards are also popular in education. It's becoming popular in education, where you can have an interactive learning experience using smart boards. So the disadvantages of touchscreens or smart boards are that they're generally quite expensive compared to their screen size. So let's say a screen size of this magnitude for a touch screen, which will cost you about $10,000 to buy one like that. So what we do is, and secondly, also touch screens are quite cumbersome. You cannot really move them around. They are fixtures. Once you fix it someplace, you cannot really move it. So let's say if you have a requirement to do a road show or a presentation in a trade show booth or somewhere, you cannot really drag your touch screen around and set it up and do a touch screen presentation whenever you want. So what we do is, instead of having a touch screen, we are going to convert existing projections or existing television screens into a touch sensitive display surface. So it's not just for televisions. It can be for any display. It can be a projection. It can be. Its application is universal. So our aim is here. Can you go back? So our aim here is to create a simple, easy to set up alternative to touch screens, which can respond to touch, voice, and gestures. Basically, the natural user interface for Kinect. All right. So this is the core idea. We'll convert any common surface or wall into a touch-sensitive display of any size. Now, naturally, when you have a touch screen, it's of a definite size. You cannot really buy for a different size of touch screen. You'll have to buy a new one. So it's not very configurable. But with a projection, usually projections are configurable in size. You can enlarge a projection, you can reduce its size, and using our application, you can convert that projection into a touch-sensitive display surface. So basically, it's much more configurable. This option is much more configurable. You can also interact naturally with these displays by touch, gesture, or voice. So you're not restricted to touch as such. You can also use voice commands. You can also use gesture commands. Now, we also make any existing display that you already have, maybe in your classrooms, that if you already have a television, we can just use this application to make it touch sensitive. So the interactive education, interactive learning is also enabled there. Now, also we can simulate a simple whiteboard from just a projection. You can draw on the screen with your hands using just gestures. Right. Okay, so to describe our product in one single sentence, we can say that Kinect Touch offers an intuitive way of interacting with projections or displays using just your hand to perform any functionalities that a mouse can perform. Basically, you can touch on it, you can drag, drop, any functionality that a mouse can offer you, any user interface that a point and click interface can offer you can be simulated using Kinect also with just your hand. All right, so we'll just show you a video before we explain the product further. We'll just show you a video on how Kinect can be used, how it can be set up. Basically, you just saw how calibration is done, so we can just show you a video for that. Okay, so this is not the actual user interface. You just saw the real user interface. This is something we made for the video alone. So what we'll be doing is is the quality too bad? Okay, all right. So what we'll be doing is we first calibrate the display using the calibration controls. You have the four corners of the screen. Once you click on calibrate, the calibration mode will start, wherein you can calibrate the four edges of the screen, which will determine the entire area to which the projection or the screen size has to be restricted. That gives you the degree of freedom of the mouse that you'll be controlling. Once you have that that data, we'll be using that data to configure a movement of mouse across the screen. So that means once I've configured the edges, the mouse will exactly move from this corner to that corner when I move my hand along the screen size. Now you also have the x-axis and y-axis corrections. Suppose the calibration you find is not very accurate, and you've already recalibrated, you've already done the calibration, you want to apply some fine tuning for it, you can use the x-axis and y-axis corrections. Those will reorient the mouse to your hand. Now those are not just for fine tuning, those can also be used to control the mouse from a distance as well. So if you change those values, the speed of the mouse changes. So if you cannot really touch a screen, if it is too far away off, if it is too high up for you to touch, you can just adjust these values and the mouse will move a farther distance when you move a small, if you have a smaller motion with your hand. Then we can continue, I guess. So at any point, if you feel that the values are not correct, you can always recalibrate those using these buttons. We'll show you the actual user interface later on. So now the mouse is enabled once you've calibrated it. So now we'll show you a couple of uses of, we'll just show you how clicks are done, how drag and drop is done with, the inset video will show you how exactly interacting with the projection there, and this screen is the actual projection, how it works. Right? At the farther corners, it's kind of difficult to control it. So now we'll show you how voice commands can be enabled. To enable voice commands, for the Kinect to start accepting your voice commands, you need to enable it first. And then once you enable it, you can issue verbal commands also for common functionalities as you use the computer for, like opening the start menu or going to the desktop or flipping through a slide presentation, like next slide, previous slide, or end presentation and all those stuff. You have commands for those. All right, I think we can continue. So here we have a voice command to enable a drag. So that's what I'll be doing here. So can you pause? So there are two modes of drag for us. One is the permanent kind of drag, wherein you activate the drag mode using a verbal command. After that, it's permanently in drag mode. You don't have any clicks anymore. So that can be used for drawing on the surface like a whiteboard functionality. Now, if you want to have just a normal drag and drop, like if you want to move things around, then you have the normal drag mode, which is activated through a gesture. So if you hold your one hand above your shoulder, that is activated, and then you move the mouse with the other hand. So it depends on which hand you want to choose. It has left hand or right hand capabilities. It depends on whether you're lefty or a righty. So yeah, we can continue then. So this is a normal drag and drop. So this is a normal click. Okay. Okay. All right. So if you notice, the video is kind of inverted there because Kinect gives you an inverted video. It's mirror. It's a lateral inversion of the mirror. It's a mirror image of your video actually. So to summarize, simple clicks can be done in two ways. Suppose you're controlling the screen from a distance. You cannot really go and touch the screen. In those cases, you can do a hover click. You can just hover the mouse over the icon that you want to click, and for a specified configurable period of time, it will consider it as a click. If you can touch the screen, then you can always go ahead and activate the simple click using a touch. Now, click delay is configurable, and there is a left-hand mode for people who prefer to use the left hand for configuration. For moving around the mouse. Now, click and drag, as I said, there are two modes of click and drag. One is for drawing on the surfaces. Suppose if you want a whiteboard functionality, then you just open a blank slide and then you can draw with your hand after activating the permanent drag. That is done using a voice command. If you want to do a normal drag, then you just use your gestures. That's it. Okay, so Kinect Touch, this also supports voice commands like the common, if you want to open the start menu, basic navigation functionalities are also enabled through voice commands, or basically flipping through the slides are also enabled through voice commands. This enables to make presentations much more effective and attractive. Okay, so the most important part in setting up this application is the calibration. If the calibration is good enough, then the end user experience is going to be much better. If the calibration is bad, then it might not respond properly to your the mouse will not respond properly to your hand. So an additional fine tuning can be done manually. Now, the display surface does not need to be perfectly rectangular, which means that you can move around the Kinect a bit and it will still not affect the accuracy at all. What the reason being, we are not really expecting the Kinect to be placed perpendicular to the display at all. You can move the Kinect around a bit and it still gives you the same result. Now, for applications, we believe this is going to have a lot of use in interactive learning as a Kinect as a touchboard interface. And it's a much cheaper alternative to the existing touchboards or the touch screens, which are much more expensive and more difficult to set up. This is something you can set up anywhere at any point. If you're doing a roadshow or if you're doing a presentation in a trading booth or somewhere, you can easily set this up and use this for navigation. It theoretically supports any screen size as well, provided it is large enough that it can detect the skeletal tracking. So the good thing is you don't really require expensive touch displays anymore. You can just use Kinect Touch. You can make any projection or any television screen sensitive to touch. Okay, so we have also found some limitations for our application. One is that it only works well with the Windows Metro interface, which have bigger icons and it's easily clickable. If you use it on a previous version of Windows, like Windows 7 or before that, the icons are much smaller and it's a bit less responsive to touch. So we would only recommend our application from Windows 8 above. And secondly, we've also found that whiteboard functionalities have certain jitter problems that is inbuilt. That's something that comes with Kinect for Xbox. But if you use Kinect for Windows, which we were not able to find here, so we were not really able to test it out on Windows. But we believe that in Kinect for Windows or the new Kinect that is coming up in November, the inaccuracies in skeletal tracking is all fixed up, and it even supports finger tracking. So in that case, if you have a Kinect 1, then it can detect your finger itself. So you can just draw or just navigate using your fingers. Right now, we are using the hand join for this tracking. So yes, the future and improvements for our application, we believe, a better accuracy for the plane can be achieved by using a 9-point calibration. Right now, we are using a 4-point calibration. We are just tracking the 4 corners of the screen. But if you use a 9-point calibration, the advantage is even if you can't reach the top corners, you can just project the height from the other 4 points. So 9-point calibration can give you a much better accuracy. And after Kinect 1 is released, we believe we'll have better accuracies for skeletal tracking, and you can use your fingers to navigate through the application, control the mouse. So we believe that that's going to greatly improve the end user experience. And Windows is also moving towards a Metro style interface, which is with tiles and stuff. So it's much more conducive to touch input, which greatly improves our user experience. So that's it for our presentation. Now we can do a demo for the application. So these are the calibration controls which we earlier saw how we calibrated it, right? So once you click on calibrate button, the calibrate mode becomes active. It shows a depth mode video cam then. And you can also configure each of these individually if you want, in case you feel that it is not correct. And here you have this is just for FYI. This determines your hand position right now. You can use the left hand mode, and these are for fine tuning and for controlling from a distance. Then this is the voice control enable. After you click on it, it enables voice control. All right. So let's just control the mouse now. Left hand. Check if it's detecting my skeleton. I'm sorry. Still detecting? Yeah. Okay. Try now. Okay, so you might have some ghost detections. Basically, sometimes it detects skeletons even if it is not there. So you just need to cover the Kinect when that happens. So now maybe we can use some voice commands. Go to start menu. So, all right. I'll do a bit of drag and drop now. Go to start menu. Go to start menu. So this is the gesture you use for drag and drop. You use the one hand above your shoulders and the other hand to drag and drop stuff. Oh, shoot. I think the Kinect is going crazy. Can you try? Can you see if the skeleton is? Why not?
Could it be the glossy screen?
Huh? Sorry?
Could it be because the screen is glossy?
I think it's because
something.
block this out. Okay, can you try again? Okay, now it's working, right? I think because of reflective surfaces, it doesn't detect the skeletons properly. Okay, yeah, those are the voice commands that we have. Let's see now. All right, it's working now. just check this filter tracking. To see if it is detecting this filter once. Can you enable right-handedness? Okay. Okay, I think we can go to the presentations now. Try voice commands. Can you enable the voice commands? Okay. So, open PowerPoint. It's open. Okay. Start slideshow. Next slide. Start draw. Okay. End slideshow. End slideshow. Exit slideshow. Yeah, okay. Still causing a problem. Can you go to desktop, Windows D?
The mouse is not detected because there's some ghosts there.
Yeah, it's always detecting skeletons that are not there. All right. Anything else that we need to show? Drag and drop. Click. Oh, okay. You can adjust the distance then. The application. Yeah, change the 0.3 or something. What is that? Oh, okay. All right. So here, if I'm trying to control it from a distance, this is how I can do it. Now the mouse movement is much faster. Okay. Yeah. So for hover and click, you can just hold your mouse at a particular position for, we have defined 4 seconds now, but it's user configurable. If you hold at the same place for 4 seconds, it will give you a click. Okay. Is that right? Okay, I guess that's it. If there are any questions.
This is the original Kinect, not the
This is the
This is the
Kinect for it's not Kinect for Windows. It's Xbox 360. So that is one problem that we are facing. Basically, its skeletal tracking is not as good as the Kinect for Windows, which has a faster skeletal tracking. It has a much better detection as well. So
for your calibration, you can go to your calibration screen.
all right.
I noticed you have this square on the bottom right. That one is to do manual calibration, is it?
Which one?
This
box?
Yeah.
This in case you
in case you really cannot do calibration, you just draw on the screen. Right?
Yeah, right. This is just to check the orientation of. This is something that we use for our own purpose. We just used to check the orientation of the screen and everything. Basically, we just said that the Kinect can be moved around, right? It doesn't really matter that the Kinect need not be directly perpendicular to the surface. You can also move the Kinect around. In which case, the surface that you are actually seeing would be a trapezoid from Kinect's point of view. So for that measurements, we just put this here as part of calibration.
Okay.
But even if it's a trapezoid, what we do is, if it's a trapezoid, then these lines are not parallel anymore. In which case, we know the slope of the lines, based on which we will dynamically recalculate how much distance is there for the y-axis. So in that case, the degree of freedom of the mouse will decrease towards that end. So that's how we calculate.
And so it's just a vector, right?
Huh?
Use it's just a ratio.
Yeah, right. We just go with the slope of the borders. That's what we do.
So if you have Kinect for Windows, will it be more accurate?
Yes, it would be, because Kinect for Windows has a much better skeletal tracking.
So this is Kinect for Windows?
No, this is Kinect for Xbox.
Yeah, for Xbox.
The thing is, you don't really get to buy Kinect for Windows in Singapore. We tried a lot of stores, but it's not available.
Funan, there is
Sorry?
There's one a few shops in Funan that has.
Okay, we went to Challenger and Best and all the main electronics shops, and they didn't have one in stock. And we have one in NUS, but that's also a Kinect for Xbox 360. We don't have a Kinect for Windows. So the thing is, Microsoft doesn't officially support Kinect for Xbox on such applications. The SDK is not supported on Kinect for Xbox. But
so how do you access it? Do you use the Kinect SDK?
Yeah, we use the Kinect SDK. Yeah. Initially, we thought of using the open, but then we thought it's much better. There is much more support for Microsoft SDKs, so that's why we're using that.
But your problem of this going onto a reflective screen will always be there, because this is the only position you can do, right? You have to be exactly behind the person.
Yes, it has to be. Yes. But you can move it around, but still the reflective surface will always be there. Yes.
Yeah, you will always have that issue.
Always have that. Yes. The ghost skeletons are always a problem, especially when it's a television screen. If it's a projection, you don't have that problem. If it's a reflective surface, then you have the problem.
So if it's on the projection, will it work much better?
It will work. Yes, it will work much better. Yes.
Okay.
Because in the video we are using a projection.
How accurate do you get? Like just now, it's not accurate at all.
It's not. It's not very accurate right now.
So,
yes.
so how is it usable? Because just now the performance wasn't usable. I mean.
Okay. All right. So if you use a projection, and if the Kinect is configured right, you get a much better accuracy. If you check the videos, that's what we did. We did it on a projection screen, not exactly a television. So
it's like really usable kind. Like,
yes, it is.
And
depends on the size of the screen also, and depends on how much your size is compared to the. Basically, it's depends on the skeletal tracking. If the skeleton is properly tracked, if the screen size is much bigger compared to your skeleton, then it's properly tracked. Yes. But if it's a very small screen, then you lose the accuracy. But there are other SDKs, open source SDKs, which can be used to improve it. Like there are some SDKs which can detect your fingers as well as of today. But those are only usable from a very close distance of 0.8 meters and so, which is not good for our application.
And okay. So technically, it's possible to use it on projection with the right environment, the light, and everything.
If you have a Kinect for Windows, it's going to be much better.
And okay, some of the comments that I have is that like those clicking and double clicking, dragging, it doesn't seem reliable here. When you demo it, I mean the dragging wasn't working.
Tracking wasn't working. Tracking was working, right?
Drag and drop. Sometimes you will have clicks.
That depends on if my hand drops below my shoulder, or if the Kinect detects that my hand is below the shoulder, even if it is not really below my shoulder, it gives a false positive. That's why it is clicking when that happens. If the Kinect accidentally goes below my hand, if the skeletal tracking goes below my hand, then it gives you a false positive. That happens, yes. But the thing is, you need an accurate skeletal tracking for it.
And if you move around in different angles, because the Kinect can only there's a certain number of angles that you can have to towards the Kinect, then they can detect your skeletal, right?
Right. So if you are
so you move around and then immediately you fish back. It takes there's a lag in between, right? Or do you handle those kind of situations?
Sorry.
Like for example, you go there and then you start walking out of the screen, and then you come back.
Right.
And does the mouse get jumping around and random stuff happen?
Does the mouse get jumping around?
I mean, as in, does it detect weird posture of the user?
Does it detect
posture? Sometimes you will.
Posture of the user.
Yeah, correct.
It doesn't
because
really depend on.
It's quite hard to use. Keep if you holding the same. I know I like your project. It's just that I'm thinking. Is it natural to do this?
You mean touching the screens?
Yeah, touching the screen and then doing something else and then going back to touching the screen.
If it is accurate enough, it's pretty good. Yes.
Okay.
Yes.
Okay.
But if it's not accurate, you have to put a lot more effort to all these things that you do. It depends on how accurate your skeleton is being tracked.
Okay.
So if it is pretty good, then you get a very good result. Yes.
Because I do some Kinect and the issue we have also is the same as yours.
Okay.
We have jumping cursors, ghosting. Just now.
For that, you can just adjust the parameters, right? The jitter parameters. If you adjust that, it's going to be much smoother. It's of course it's not going to be as accurate as it is, but it's still going to be very smooth if you adjust the parameters for it. But ultimately, yes, it is. If we have a better skeletal tracking, which we expect in Kinect 1, it's going to be much better because the skeletal tracking in Kinect 1 is going to be at the finger level as well.
Yeah.
You can detect the fingers, and plus the skeletal tracking is faster. It's much faster than what you have in the current processing. Right? Yeah, then you don't have the lag. Yes. Right. So yes, this as of now it is kind of premature. You cannot really do this on a Kinect for Xbox. But with Kinect for Windows or with Kinect with Kinect 1 that is coming out in November, I'm pretty sure it's going to be extremely good.
Then what's your future plans for this? Are you going to?
I think once Kinect 1 comes out, I think we'll try to improve this a bit further.
Kinect 1 is not going to come out anytime soon, right?
In November, right? It's coming along with
might
the
not
Xbox.
be available in Singapore. Kinect 1 is Xbox One is only available in Singapore end of next year.
End of next year?
Yeah, it's not even this
but
year.
It comes out in US this year, I guess. Oh, okay.
Correct.
So, right. Oh, then
so
it's
from
going
now
to be.
Then, the only thing that you can have is Kinect for Windows 3 out.
Yes.
Yeah.
Right.
But what is your plan? Like,
actually, Kinect has a lot of. The thing is, it's still a premature area. If you look at Android or other kind of trendy stuff, it's almost saturated. But natural user interface is still a growing area. I think there's a lot of potential in that area. There is a lot of scope for improvement in a lot of apps that are possible using a Kinect. So,
but what's your future plan for this?
For this?
Yeah.
For this, I think unless we have better skeletal tracking, we might not be able to do a better job. But of course, with a 9-point calibration, the accuracy can be improved. Yes. Yeah. In case you are not able to reach up to the corners for calibration, you can always project the distance with a 9-point calibration. We initially planned for that, but then actually we are doing. This is an implementation of a paper that was written last year.
Yeah, this is not the first time I've seen it.
Yes. In 2012, there was a paper written on the same subject, and we used the paper for implementing this. Yes.
But you will still be a research project.
Sorry?
You are not going to commercialize it.
It's a research thing. It's just a, what do you call it? It's not a commercial thing yet. Unless the accuracy improves, it's not a commercial thing. Yes.
Okay. Because I have a Kinect for Windows. I can loan you.
Oh, okay. You
can
have a
try
Kinect.
out.
But where did you get it again? Because we searched a lot of places and we never found it.
But it's hard to get.
Yeah, it's hard to get in Singapore. We initially thought of ordering it on eBay, but it didn't work out.
Okay, wait. If Kinect with Windows, can he just plug in like that?
Yeah, just plug in and use.
Oh, you have it now?
We
No, I
have
don't
one.
have
There's supposed to be one. I don't know where it went.
Oh, okay.
Yeah. So
And you
basically,
have one, or?
the one they're plugging in now should be the Kinect for Windows. For some weird reason, I assume this is yours.
Yeah, this is mine.
Yeah.
But the other Kinect is also like 360. It's not Kinect.
Yeah, they're supposed to be Kinect for Windows.
Oh,
Like
okay.
we key on from Microsoft. I don't know where the thing went.
Okay. The thing is, we had initially talked with Johnson there, and the Kinect was
Yeah.
still 360. So
I'll check for you. Then hopefully, at the showcase, you can use the
Yeah.
Yes.
Windows one. Yeah.
right.
If
Maybe
you
for
don't have it,
developers, it is
I'll
better.
pass
to
you
use
the one so that on your showcase we can see it again.
Oh, great. Okay.
No,
You don't need- you don't
no
need
code
to
change,
get
right? No code change, right?
Right. Okay.
You should just plug in and you should work the same.
Okay. Great. All right.
And that one got near distance, so you don't need to.
Oh yeah. Right. Yeah. Kinect for Windows is needed.
4D meters. No, 4 meters more. Not 40.
0.8, right? Like near mode for Kinect Windows works from 0.8 meters, I think.
0.4 to 0.8.
Oh,
0.8
okay.
is the normal one.
Oh, all right.
Yeah.
Okay.
There's two modes there's a near mode and a normal mode.
Okay.
Yeah.
So you're saying that Kinect 1 doesn't come out very soon, anytime soon. I was expecting it
I
to come
know the
out
Xbox One is not coming out anytime soon. I don't
okay.
know whether the Kinect is the same timeline as the Xbox One.
But there is going to be a developer version for Kinect also in Kinect 1? Like
they,
Kinect for Windows?
they didn't announce the Kinect for Windows version 2, right? They only announced the
Xbox. Yes.
Kinect, right?
Right.
Yeah. So there's no announcement, we don't know.
Okay. Yes, but it's still in infancy, I agree, because I mean, with the current tracking, this is the best we can do. But yes, with an more accurate tracking or with more accurate devices, we can do better job. Yes.
Yeah, because it's not meant for.
Yeah, it's not meant for
Not meant for.
Okay.
All right, so I guess that's it. Thanks.
Thank you.
Thank you.